Hi, nice to see you. This video is about all advanced functions that are useful to control subwoofer array directivity in a simple and intuitive way with RDNet. The curve function allows the natural curvature of a horizontal array made of equidistant subwoofer to be electronically simulated in order to control its horizontal polar pattern. For example, this is an acoustic simulation showing the sound field at the frequency 63 Hz of a subwoofer array from a top view. This type of arrangement tends to concentrate most of the energy available on the perpendicular to the array center, uncovering the lateral areas. Physically bending the array, it is possible to control its polar pattern, ensuring a more uniform sound coverage throughout the listening area, with a consequent improvement in the sound reproduction quality. To make a new curve function, select with the mouse, click and hold to make an area, all objects to be assigned to the function. Or right-click an object and select Functions New in the menu. Available parameters are angle, which expresses horizontal coverage angle of the entire array. The algorithm will calculate the delay to be applied to each subwoofer to get the coverage required by this value. Distance is between two subwoofer axes. The algorithm needs this value to calculate the delay values to achieve the required angle. For a correct operation, all subwoofers should be arranged on a straight line and equally spaced by the exact value here specified. The distance between two subwoofer axes determines the maximum operating frequency of the entire array. Increasing this value reduces the maximum frequency. The max freq is a value calculated by the algorithm and is the maximum operating frequency of the subwoofer array. It shall be always higher than the low-pass cutoff frequency. Group by allows you to group individual elements of the array by this number. The algorithm will assign all calculated delays to every subwoofer stack instead of each single object, considering the stack as if it were a single sound source. Click Disabled to disable the curve function, removing all object delay settings. There's another option to control subwoofer directivity: end-fire or gradient configuration. This configuration is achieved by aligning two subwoofer or two subwoofer array in the same direction and placing them in front of each other. The subwoofer A is delayed to virtually overlap the subwoofer B. This way allows the maximum sound pressure to be obtained and the cancellation of a part of the sound spectrum behind the speaker. Typically, the frequency wavelength at which the cardioid effect, so the cancellation, is 4 times the distance between the speakers. The figure displayed shows the simulation of an end-fire configuration at 50 Hz, 1/3 octave. The distance between the two sources is 1.72 meters. Therefore, the wavelength of the frequency to get the maximum rear cancellation is 4 times 1.72, which is 6.88 meters, which correspond to the frequency 50 Hz. Subwoofers in the gradient configuration have a polar pattern comparable to that of directional microphones. This means, unlike the end-fire configuration, cancellation will be present, so cardioid effect, at all frequencies sent to speakers. The gradient configuration represents the only way to control the polar pattern at low frequency and can provide, when properly set, useful patterns that allow the listening area to be shaped at low frequencies according to your needs. Conversely, compared to the end-fire configuration, in the gradient configuration the subwoofer B is delayed, but in this case its phase is 180 degrees. In that figure, speaker's behavior can be compared at different frequencies, at 1/3 octave. In the gradient configuration, the directionally is more pronounced at all frequencies, while only at 50 Hz it can be compared to the end-fire configuration. To work with the RDNet for this purpose, you can proceed selecting with the mouse the objects that you intend to assign to the function. Check that the order of the object is correct, with the first device on the top left and the last one on bottom right, by using the first number on the device name. If the order is not correct, you have to move devices on the working area. Click on the right mouse button and select Function, New and Fire. With rows, it means the number of row subs. With distance, the distance between the center of two subs of two different rows, in meter or millisecond. And at the end, with group by, the number of sub for each stack, the same as in the curve function. When leaving the sources at the same places, this RDNet function also allows, with just a click, switching from the end-fire to the gradient configuration. In this way, it is possible to compare in real time the performance of the two different configurations, with obvious advantages when optimizing sound reinforcement system. Furthermore, on stage, you will be able to appreciate the difference in the cardioid behavior of the two different configurations. Thank you for watching. Bye bye!